This is review recording 1A and B to accompany instructional recordings 1A and 1B for Section 7.3 of Unit 7, Chapter 7, Mathematics 2200. We'll solve absolute value equations graphically and algebraically. Example 1. How many solutions does the equation absolute value of x squared minus 1 plus 5 equal 2 have? The simplest way to go about this one is to isolate the absolute value part. So we have absolute value of x squared minus 1 equals 2, subtract 5. Absolute value of x squared minus 1 therefore is equal to negative 3. But recall, absolute value is always greater than or equal to 0. So therefore there is no solution. Our answer is A. Graphically speaking, if we graph the right-hand side, y equals negative 3, that is a horizontal line. The left-hand side, y equals absolute value of x squared minus 1. To graph that, we first consider y equals x squared minus 1. It has vertex at 0, negative 1. And it has x-intercepts when x squared minus 1 equals 0, which means when x minus 1, x plus 1 equals 0, at x equals 1, and x equals negative 1 therefore. So there we have that those 3 points. We sketch that guiding graph and then use reflections as necessary, reflect the negative part and keep the positive parts of the guiding graph, and we get the absolute value graph. So there are no points of intersection, therefore no solution. Example 2, we solve graphically and algebraically. We're going to graph the left-hand side separately from the right-hand side. So graphing the right-hand side first, y equals 2x minus 12. That has a slope of 2 and a y-intercept of negative 12. So I'll just start at negative 12 for the y-intercept, go up 2 over 1, up 2 over 1. I'll label this graph, y equals 2x minus 12. To graph the left side, y equals absolute value of x squared minus 6x. Well, first of all, consider y equals x squared minus 6x. It has x-intercepts when x squared minus 6x equals 0. So we'll factor that, x outside of x minus 6 equals 0. So we get x equals 0 and x equals 6. We have a point right there and a point right there. And I've decided to color code it so we can keep track. Alright, so we have the x-intercepts. Now we need the vertex. So our vertex, negative b over 2a equals negative of negative 6 over 2 times 1, which gives us 3. And we plug that in. 3 squared minus 6 times 3 gives us negative 9. So we would have a vertex there at 3, negative 9, which would be way right down here. So I've dashed in that guiding parabola. Then for the absolute value graph, I keep anything that's already positive and reflect anything that was negative. So 3, negative 9 becomes 3, positive 9. I've sketched in my reflected portion, and now I label my graph. And there's only one point of intersection right here between the line and the absolute value graph. That's at 6, 0. So our solution is x equals 6. Now for the algebraic solution, we've got absolute value of x squared minus 6x equals 2x minus 12. We therefore have two cases. Case 1, where the positive of x squared minus 6x equals 2x minus 12. And case 2, where the negative of x squared minus 6x equals 2x minus 12. In the first case, I rearranged that quadratic equation. X squared minus, bring over that 2x and subtract it, I get minus 8x plus 12 equals 0. So I've got x minus 6 x minus 2, a little bit of a brain freeze there for a moment. And we've got x equals 6, x equals 2. I want to check both of those. So the absolute value of 6 squared minus 6 times 6, is that equal to 2 times 6 minus 12? 6 squared is 36 minus 36 here gives us 0. Absolute value of 0 is certainly equal to 2 times 6 minus 12, which is 0 as well. So we're good there. On the other hand, when I substitute the 2 in, I get absolute value of negative 8 is equal to negative 8. But that would mean 8 equals negative 8. That's not true, so x equals 2 is extraneous. For case 2, I have to distribute the negative in, so I've got negative x squared plus 6x equals 2x minus 12. Bring everything to the right-hand side so that I've got a positive x squared. Makes my factoring a little easier. And 2x minus 6x will be minus 4x minus 12. Bit of factoring gives us x minus 6, x plus 2 for the factors. So x equals 6 and x equals negative 2 are possible solutions. Now the x equals 6 I've already checked in case 1, so that's a solution. X equals negative 2, when I substitute it in, I end up getting 16 equals negative 16. So x equals negative 2 is extraneous. In summary, when solving graphically, graph the left side and the right side of the equation, find the points of intersection. If there are points of intersection, the solutions are the x-coordinates. Make sure you check your solutions in the original equation. I waited till I did the algebraic solution to do that. When algebraically solving, an equation of the form absolute value of an expression is equal to a second expression, there are 2 cases to consider. Solve the equation in each case and check solutions to see if there are extraneous roots.